Hello everyone, we are Virtual Engineeria and this is Electroverse. We are here in our single-phase circuits laboratory. In this video, we are going to make a parallel connection of two resistors. Our circuit will look like this. Here we have our powerful power source, the variac, which is adjustable. Let's connect an ammeter. We're going to connect another ammeter here. Here we'll have another ammeter. Here's a resistor, it's variable. Another resistor, which is also variable. And here we will close the circuit. And we will also connect a voltmeter. This voltmeter will go right here. What are we going to observe? That we will have a current passing here, a current I passing here, and here it will split. Upwards, I'll have an I1 current indicating the upward direction, and down here, I'll have an I2 current. And the sum of this ammeter with this ammeter will be this current, and the voltage across the circuit won't change even if I vary both resistors. So that's it. Let's start our assembly right now. I'll take a small electronic resistor. I'll put it up here right now. This one I'll place more over here. I'll get two more ammeters. Please go ahead and put one right here in this spot. Just place it here as indicated. One down here. This one, as you can see, will go. This particular one will go right here in this specific spot. And I'll put the voltmeter here. That's it. Perfect. Let me lock everything in place here. Done. Thank you for your time. So, at this point, let's proceed on to the connections. And now, right here in this spot, I'll go ahead and make this connection right here, just like this. Finally, I will now carefully connect the voltmeter to the circuit. Now I'm going to set it to 250 ohms here by carefully adjusting the control knob on this device making sure to watch the display closely until it shows exactly 250 ohms. And, well, here as well. That's it simply. Alright guys, because the resistors are actually in parallel. The way parallel works is that since they're equal, we just simply divide by 2. The parallel resistance, the equivalent resistance of a parallel circuit, is R1 times R2 over R1 plus R2. In our particular case here, that's a resistance of exactly 125 ohms. If I apply this value, my total circuit current will be 100 volts, which is the voltage I am going to use, divided by 125 ohms. If I divide this here by 25, it's 4. If I divide this by 25, it's 5. So I'll have 0.8 amperes. So let's apply the 100 volts. Here's the power source. With 101 volts applied, I have 101 volts here and 0.81 amperes, which is what we calculated, and the current splits equally, 0.41 down, 0.40 up. If I add 0.41 to 0.40, I get 0.81. And the voltage across these two resistors that are in parallel is 101.67, which is exactly the voltage of the power supply. Guys, I'm going to do the following. I'll vary the resistances to show how the currents change. So I'm going to decrease the resistance at the bottom. When I decrease the resistance at the bottom, notice that since the voltage is constant, the current tends to be higher. So look, the total current in the circuit increased, and the current in the lower branch is higher than in the upper one. Whereas if I increase it, see what happens. I'm raising the resistance, and the current just keeps dropping. Until I get to I'm reaching 450, 440, I have 0.63, 0.23, my I2 is at 0.23 and my I1 is at 0.4. Now I'm going to adjust the top one, I'm decreasing it, the current is going up, look. So 56 ohms, current of 1.81 amperes, total circuit current 2.04. I'm going to gradually increase this resistance and slowly decrease the current until I reach a point where it tends toward a lower value. So that's it, folks. In a parallel circuit, the currents split and we can adjust them according to the resistances in parallel. So that's it, folks. That's it for today's video. Take care and see you next time.